Hello, everyone. My name is Jayraj Boghani, and I'm a master's student in construction management and technology at Arizona State University. Today, I'm excited to walk you through my project, the Nighttime Work Zone Lighting and Safety Improvement Plan. This research bridges the gap between academic insights and practical field applications for improving safety during nighttime construction work. Let's begin with a simple observation. Nighttime construction is increasingly common because it helps avoid daytime traffic congestion. However, one major trade-off is poor lighting, which increases risk for both workers and passing drivers. During my site visits, I observed uneven lighting coverage, frequent dark zones, and harsh glare that could impact visibility and safety. That's where my idea came in. Why not develop a simple, user-friendly tool and layout strategy to improve how lighting is planned? This led to my project's main objectives. First, I assessed current lighting methods used in work zones. Then, I identified key safety challenges related to poor illumination. I developed a lux calculator using Excel to estimate brightness levels. I also designed a basic lighting layout to minimize dark spots and glare. Finally, I compared lighting tower types, LED, metal halide, and solar, to recommend the best solution that's practical and compliant with safety standards. This led to my project's main objectives. Rooted in trusted literature. I assessed current lighting methods
According
used
to the
in work
FHWA,
zones. Then,
proper lighting
I identified
can reduce
key
crash
safety
rates by up
challenges
to
related to poor
30%.
illumination.
The Texas
I
A&M
developed a lux
Transportation Institute
calculator
found that
using
metal
Excel
halide lights
to
create more
estimate
glare,
brightness levels.
while
I also
LEDs are
designed a
generally
basic
preferred
lighting
for their
layout
focus
to
beams.
minimize dark spots.
An article in the
and glare.
IT Journal
Finally,
emphasized a
I
strong
compared
link
lighting
between
tower
poor
types,
lighting and higher
LED,
accident rates.
metal halide,
From a
and
regulation
solar,
standpoint,
to recommend the
OSHA
best
requires a
solution that's
minimum of
practical
5
and
foot
compliant
candles,
with
or
safety
roughly
standards.
54 lux
This led
for
to
work
my
zone
project's
lighting.
main objectives.
And the MUTCD
First,
provides
I
layout and
assessed current
spacing
lighting
guidance
methods
that help
used
shape
in
my
work
lighting
zones.
plan.
Then,
The foundation
I
of this
identified
project
key
is
safety
here's how I
challenges
tackle
related
the
to
trusted
poor
literature
illumination.
step by step.
I developed
According
a
to the
lux
FHWA,
calculator
scope,
using
proper
Excel
focusing
to
on reducing
estimate
crash
brightness
rates by up to
levels.
30%.
I also designed a basic
I
lighting
lighting
layout
transportation
to minimize
found
dark
that
spots
MUTCD
and glare.
lights create more
Next,
glare. I dove
I
into
compared lighting
LEDs
tower
are
types,
generally
LED,
preferred for their
metal
focus
halide,
beams
and
and lighting
solar.
product.
An article in the
recommend
IT
the
Journal
collected
emphasized
technical data
strong
from major
and
lighting
compliant
poor
with
lighting
safety
and higher
standards.
accident.
This led to my
Allman,
project's
from a
main
regulation
objectives.
standpoint.
Then,
First,
OSHA
I
requires
created
a
a
minimum of
5
5
foot
lux
lux
calculator
calculator,
roughly 54
and used it
lux
to
for
evaluate
identified key
multiple
safety
scenarios
challenges related to
I
poor
designed a layout
illumination.
spacing guide
I developed a
30
lux
lighting
calculator
two-lane
using
road
Excel
segment
to
and
estimate
compared
brightness
towers
levels.
based
I also
on light
designed
intensity,
a basic lighting
spread,
layout to minimize dark
practicality.
spots and glare. Finally, I compared lighting tower types, LED, metal
This
halide,
is the core
and
tool
solar
I developed
to
It
recommend the
takes
best
simple
solution that's
inputs
practical
like lumens
and
per
compliant
light,
with
total
safety
area
standards.
to be
This
lit,
led
and
to my
number of
project's
towers.
main
It
objectives.
calculates the lux
First,
level
I
using the
assessed
formula.
current lighting methods
Lux
used in
equals
work
total
zones.
lumens
Then,
divided by
I
the
identified
area.
key safety
For example,
challenges related
with
to
two
poor
LED
illumination.
towers producing
I developed a lux
110,000
calculator using
lumens
Excel
each and covering
to
210
estimate brightness
square
levels.
meters.
I
The
also
result is
designed a basic
approximately
lighting layout to
1,047
minimize
lux,
dark spots
which
and
is
glare.
far above
Finally,
OSHA's minimum
I compared
requirement.
lighting tower types.
This kind of tool makes
LED,
lighting planning
metal
easier,
halide, and
especially
solar
for field
to
engineers
recommend the best
who don't
solution
use
that's
specialized
practical
software.
and compliant with safety standards. This led to my project's main objectives.
Here's the layout I proposed.
First, I
Two
assessed
towers
current lighting
are placed
methods
on
used in
opposite
work
sides
zones.
of the road to reduce
Then,
shadows.
I identified key
The light
safety
beams are
challenges
angled
related
inward,
to poor
overlapping
illumination.
slightly
I
to
developed a
eliminate
lux
dark spots.
calculator using Excel
Each
to
LED
estimate
tower
brightness
covers
levels.
a radius
I also
of
designed
35
a
to 40
basic
meters.
lighting layout to
The setup
minimize dark
minimizes
spots
glare
and
for
glare.
drivers while ensuring
Finally,
the work
I
area
compared
is
lighting tower
properly lit.
types, LED,
This
metal
layout
halide,
balances worker
and solar
safety and driver
to recommend
comfort.
the best solution
key
that's
factors
practical
in
and
nighttime
compliant with safety
construction.
standards.
I
This led to
evaluated
my
different
project's
tower
main
types
objectives.
to see which one
First,
performed
I
best.
assessed current lighting methods
LED
used in
towers
work
came
zones.
out on top.
Then,
They
I
offer better
identified
brightness,
key safety
energy
challenges
efficiency,
related to poor
and
illumination.
superior glare control.
I developed a lux
While metal
calculator
halide towers
using
are
Excel
cheaper up front,
to estimate
they fall
brightness
short in
levels.
terms of light
I
quality
also designed
and
a
energy
basic
use.
lighting layout to
Solar
minimize
towers
dark
are
spots
eco-friendly,
and glare.
but currently
Finally,
lack the output
I
needed
compared
for larger
lighting tower
or
types,
high-traffic
LED,
zones.
metal halide,
No
and
project
solar
is without its
to recommend
challenges.
the best
I
solution
didn't have
that's
access to
practical
advanced
and
lighting
compliant with
simulation
safety
tools like
standards.
Dialux
This
or
led to my project's
AGI-32.
main
Also, I
objectives.
lacked a lux meter,
First,
so
I assessed
real-world
current lighting
validation
methods
was
used
limited.
in work zones.
Scheduling interviews with lighting
I
experts
identified
proved
key
difficult.
safety challenges related
Finally,
to
environmental
poor illumination.
conditions like fog
I developed
or
a
dust
lux
were not modeled,
calculator
but are
using
important
Excel
factors to consider in
estimate
future
brightness
improvements.
levels. I also designed a basic lighting layout to minimize dark
Based on my
spots
findings,
and glare.
I recommend the use
Finally,
of LED
I compared
towers
lighting
for
tower
most
types,
nighttime
LED,
construction projects,
metal halide,
due to
and
their
solar,
consistent
to
performance
recommend
and
the
low
best
glare.
solution that's practical
Field teams
and
should also
compliant
use
with
basic
safety
planning
standards.
tools like
This led
the
to
Excel
my
Lux
project's
calculator
main
to ensure
objectives.
they meet OSHA
First,
requirements
I assessed
before
current
setup.
lighting methods used in work
Further
zones.
improvements could include
Then,
integrating
I
simulation
identified
software,
key safety
conducting
challenges
field
related to
tests with
poor
lux meters,
illumination,
and training
I
site
developed a
managers
Lux
on effective
calculator
light
using
placement.
Excel to
To wrap up,
estimate brightness
this project
levels.
helped me
I also
understand
designed
how
a
crucial
basic
lighting
lighting
is for
layout
nighttime
to
safety.
minimize dark spots
I created a
and glare.
practical set of tools.
Finally, I
a Lux
compared lighting
calculator,
tower types,
a lighting layout
LED,
sketch,
metal
and a
halide,
comparison
and
table
solar
to guide
to
equipment
recommend
selection.
the best solution.
Although I
that's
didn't have
practical
access
and
to
compliant
advanced
with
simulation
safety
software,
standards.
this
I believe
led
the
to my
foundation
foundation
I've built
main
is strong.
objectives. This
First,
approach can
I assessed
absolutely
current
help
lighting
improve
methods
planning
used in
and
work
reduce
zones.
risks on actual
Then,
construction
I
sites.
identified key
More
safety
importantly,
challenges
it shows
related
how
to
simple
poor illumination.
tools and awareness
I developed a
can make a
Lux
big impact in the
calculator
field.
using Excel to estimate brightness levels. I also designed a basic
My
lighting
research
layout
was supported by
to
key
minimize
standards
dark
and documents
spots
from
and glare.
OSHA,
Finally,
MUTCD,
I compared lighting
the
tower types,
FHWA,
LED,
Texas
metal
A&M,
halide, and
TTI,
solar
and
to
product
recommend the
manuals
best
from
solution that's
Wenco,
practical
Almond,
and compliant
and
with
Generac.
safety standards.
This led to my
Thank you for
project's
your time
main
and attention.
objectives.
First, I assessed current lighting methods used